Okay, good evening everyone. So I'm from the University of New South Wales and I'm talking about Betelgeuse. So that's Betelgeuse the star. Betelgeuse the star, it is not Betelgeuse the movie or the play. Now, what's happening with Betelgeuse? There's been a bit of publicity in the paper about Betelgeuse. Will it blow up in 100,000 years tomorrow or some other time? Will it explode and kill us? So that's what I'm going to talk about. Now, there's Homer there, just returning in his spaceship, and he finds that the Earth has been destroyed by Betelgeuse, a supernova. Could that possibly occur? Okay, now the thing about Betelgeuse, it's a super giant, but that's not the main thing about it. Okay, you're not going to believe this, but Betelgeuse is heading towards the Earth. And Betelgeuse is actually travelling faster than the speed of light towards the Earth. Now that is an extraordinary claim. As Carl Sagan said, if you're going to make an extraordinary claim, you've got to have an extraordinary evidence. So I'm going to present that here. Okay, in 2010, it was 650 light years away. 10 years later, it's 450 light years away. Now that tells us that Betelgeuse is moving towards us faster than the speed of light. You can't get any evidence better than that. Now that will, you can scrutinise that as much as you like, but that's absolutely fantastic. That should convince you on that. Okay, put your hand up if you believe me. Put your hand up if you don't believe me. Okay. Put your hand up if you believe me if I was Donald Trump. Okay, alright, so, okay, that's good. That means the audience hasn't had that much to drink. Okay. Now, Betelgeuse is a super red giant towards the end of its life. The big stars don't last very long. They only last about 10 million years. There's a bit of information about it there. It's the 10th brightest star. It's actually got about the right distance, although there's a large error bars in there. It is much larger than the sun. Now, everyone knows what the mass of the sun was. If you were to walk on the street and say to someone, "Hello, how are you? Who's the Prime Minister?" I probably couldn't tell you. But if you asked them what was the mass of the sun, they could tell you what it was. Okay, Ian, from the front here, what's the mass of the sun?
One soul of man.
I also heard someone from the back say it's 1.6 times 10 to the power 30 kilograms. That's incorrect. It's 1.7 times 10 to the power 30 kilograms. Okay, it's quite cool. It's 3,500 degrees. Our sun's around about 5,000 or 6,000 degrees. It is extremely large. How large? Okay, I'm not sure you can see the screen very well, so I'm going to actually walk up here. I think I am. Okay, if I move out of the way. Right, there's Jupiter here. There's the Earth, so small you can't even see it. There's Saturn. So Betelgeuse is somewhere between the size of Jupiter and Saturn, so extremely large. Now, using our ALMA radio telescope, there's some information about it, and that's what it would look like. That's a simulation there, but if you get close enough to it, it looks something like that there. Actually, this is not a bad spot here. I might stay here. Okay, so Betelgeuse is extremely large. Extremely large. Okay, so what's happened to Betelgeuse? It's actually getting dimmer at certain times. So in January 2019, all the way through to March 2020, you can see the graph down here is actually getting a lot dimmer. It's actually getting 2 or 3 times dimmer than what it was originally, but it is bouncing back like most people. it's actually starting to get to about the right size now. So why was Betelgeuse actually dimming? Now, some people thought, oh, it was about to go supernova, that must have been a reason. Okay, well, let's see. All right, what they think is giant dust grains are responsible for Betelgeuse's dimming. So the star is actually pulsating. It's giving out quite a few Earth masses, and these can get in the way over here, and that can cause the light to be absorbed, so it looks like it's dimming. That seems to be the main reason people think about it. Okay, so you can have a graph here, actually see how it's going up and down, pulsating. It's in the yellow and the blue.
What's the y-axis?
The y-axis, okay, yes. So what we have here is a magnitude. Now, Betelgeuse is quite bright, about 10th brightest star. So a magnitude 1 and a magnitude 2, that's a difference of 2.5 times. So if it's on 1 and it goes to 2, it's 2.5 times the bright. Sorry, if we're going from 2 to 1, it's 2.5 times as bright. Okay, so it is pulsating, and there's some information there about it pulsating. A bit over a year, and over a long term, it's also you can do graphs of it as well. Okay, so it's a supergiant star. It spends most of its time with hydrogen and helium, about 10 million years. Our sun's 5 billion years old. And then it goes helium to carbon, which is a much shorter scale. Carbon to neon, 200 years. You can see what's happening here. It's almost like a countdown. Neon to oxygen, 40 years. Some people actually thought it was somewhere around here at one stage. Oxygen to silicon, 3 months. Oh, you'd be worried about that. And silicon to iron, well, guess what? They wouldn't even last the rest of the night, probably. Okay, so once it gets to here, it is very, very quick, and you get this supernova over here. And as the cartoon says, you don't see one of those every day. Now, what it means is how what we think could go anytime between 10,000 years and 100,000 years. I'm hoping for the 10,000 years. I can't wait 100,000 years. Now, when it does go, you will know about it. It's going to be as bright as the moon. You can imagine that, you know what the moon's like during the night time. It will be as bright as that. And you will be able to see it very, very clearly during the day, except it's pretty much a single point, unlike the moon. Okay, so because you have these hydrogen burning, silicon burning stuff, it's like an onion. You've got different layers in there. Okay, so will we survive if these people don't worry about themselves, I suppose. Don't want to be the only ones left on the planet. Will we survive if Betelgeuse goes supernova? Well, recent research has shown that a supernova about 25 light years away would lead to a biological cataclysm. Now on the movies they call it ELE, E-L-E. Anyone know what that stands for? Event, ELE, Event Extinction Level. Okay, on the movies. So you get a mass extinction. Now this happened about 359 million years ago, where 70% of the Earth's invertebrates died, and they think this thing was about 65 light years away. Now there are supernova, bigger ones, and they are all different sizes, but 65 light years away is probably about the spot that you don't want anything to be closer than. So the good news is there are no stars close that could go supernova. Okay? That's the good news. Okay, so we are safe for now. All right, thank you.